Okay, this is the review for the linear 3 test. So question 1 says, does the graph represent a function? And it wants us to explain why or why not. So remember, when we're looking at a graph, we can use the vertical line test. And if our vertical line crosses our graph more than once, then we know that it's not a function. And you can see here that it's going through it more than once, so therefore this is not a function. And whenever our vertical line test is crossing our graph more than, or when it touches our graph more than once, it means that we have repeating x values. So that's how we know that it's not a function. So we're going to say because repeating x values. Okay. So question number 2. It says, does the table show y as a function of x? And again, it wants us to explain why or why not. So we're looking for the same thing, but this time on a table if we have repeating x values. So we say we have -9, 1, 3, 9. So therefore, we do not have any repeating x values, so we know that this is a function. And we're just going to simply say because no repeating x values. All right, question number 3. Is the relation on the right a function? And again, it wants us to explain why or why not. So when we look at our mapping here, we're looking to see if any of the x values has more than one arrow pointing to 2 different numbers. So if we come down here to 15, we see that 15 gives us an output of 7 and 9. So that tells us right away that this is not a function because of repeating x value. Okay, number 4. Which of the following relations are not functions? So we're looking for the ones that are not functions, so we're looking for the ones that have repeating x values. So starting with 1, we have 3, 5, and 7. So those are not repeating x values, so we can scratch this one out. So when we come to 2, we have -2, 5, -2. So these -2s that are repeating tell me that this one is not a function. Here at 3, we have 7, 7, -1. So 7 and 7 are repeating. Those x values are repeating, so we know that this one's not a function. And then for 4, we have 10, 11, 12. So we have no repeating x values there, so that one is a function. So our answers are going to be 2 and 3. Okay. So it says, use the following situation for numbers 5 through 6. Sorry about that. For numbers 5 through 6, it says Zoe is saving to buy a bicycle. She started with $30 and adds $1 per day. So based on the situation, what does the $30 represent on a graph? Okay, so it says right here she started with $30. So that is my starting value, my initial value. So since that's my initial value, that means my 30 is my y-intercept. And we know that because it's the initial value. Okay, and then 6 is saying, based on the situation, what does the $1 represent on a graph, and how do we know? So right here, when it says it adds $1 per day, that per right there tells me that the $1 is my slope. And we know that because of the keyword per. Okay. Moving on to number 7. So it says the graph of a candle's length after being lit is shown on the right. Identify the key features of the graph. Okay, so 0, we have to remember 0 is another name for our x-intercept. So that's where our graph is going to cross the x-axis right here. So when we look at our graph, we see that it crosses at 100. So therefore, my 0 would be, and I'm going to write it as a point, 100, 0. Okay, so the y-intercept is where the graph crosses the y-axis, so it's crossing at 10, so therefore I know that my y-intercept is 0, 10. And then my rate of change, since we have a graph here, we're going to use the rise over run. I know that it's going to be negative because my graph is going down. So I'm going from here to here. I'm going down 1, 2, 3. So I have 3 over. And then we're counting by what here? 10. So that's going to be 10, 20, 30. So negative 3 over 30. And I know I can reduce this because 3 and 30 share a common factor of 3. So this is going to actually be negative 1 over 10. Okay. Number 8. It says graph f of x equals negative 3x plus 6, and then it wants me to identify the 0, the slope, and the y-intercept. I know that I can go ahead and identify my slope just by looking at the equation, because remember my slope is the value that's always attached to x, so it's negative 3. And then my y-intercept is always the lonely one out there by itself, so this one's going to be 6. And from here I can start graphing it. And my beginning point is going to be my y-intercept, my 6. I'm starting right here. And then to make this a fraction so I know how I move, I'm going to put a 1 under it since it's a whole number. And then from here I know that I'm moving down 3 and right 1. So we're going down 3 and right 1. And that gives us enough where we can easily find our x-intercept. So we'll go ahead and connect our points here. And we have a 0 of 2. So we'll put 2, 0. Okay, number 9. 9 says graph y minus 2 equals 1 over 4 times x plus 8. And then it wants us to identify the key features. One thing that we can go ahead and identify from our function here, and we have to recognize that this is in that point slope form, and this value right here is my slope. So my m equals 1 over 4. And since this is in point slope form, then I also know that I can pull an x and y value out for a point. So remember, this one right here is my x value, and when I pull it out, it's always going to be the opposite. So since it's positive here, I know it's going to be a negative 8 when I pull it out. And then this minus 2 right here, this is my y value. And when I pull it out, it'll be the opposite as well, so it ends up being a positive 2. So this is where I'm going to start at, is negative 8, 2. So negative 8 is going to make 2, yeah, 2. And then based on my slope, I'm going up 1 and right 4. So up 1, and then 1, 2, 3, 4. And then up 1 and 1, 2, 3, 4. Okay, and then to go backwards, I'm going to go down 1 and then left 4. Down 1 and left 4. Now I'm going to connect all my points here. Okay, so my 0, again, that's where my graph is going to cross the x-axis. I can see that's at negative 16. So this would be negative 16, 0, written as a point. And then my b value, my y-intercept, this is 4. That's where my graph is crossing the y-axis. Okay, moving on into number 10. Number 10 says to identify the key features of the graph. So I'm looking for the 0, so I'm going to go over here to the x-axis and see that we are crossing at 8. So this is 8, 0. Then it wants me to find the y-intercept. This is where it's crossing the y-axis, so that's right there at 4. So that's 0, 4. And then my slope, I'm going to have to find that by finding 2 perfect points on my graph. So I'm going to use my y-intercept and this point right here. I know that it's negative because it's going down. So I'm going to go to put my negative sign. And I see I'm going down 1 and then over 2. So my slope would be negative 1/2. Okay, let's flip it on over to the back side. Okay, so number 11 says a line has a slope of 7/5 and a 0 of -5, and it wants to know what the y-intercept is. So what I'm going to do in order to find my y-intercept is go ahead and put this on the graph so I can find it where it crosses my y-axis. So I'm going to start at the x-intercept of -5, so that's right here on my x-axis. And then since my slope is 7/5, that means I'm going up 7 and right 5. So starting here, I'm going up 7 and right 5. And I can already tell that my y-intercept is 7. So that's what I'm going to fill in there. I'll go ahead and connect my points. Okay. Number 12 says, what are the x and y intercepts of 6x plus 18y equals 54? So this is that standard form. And in order to find the x and y intercepts, we just plug in what our y value would be for the x-intercept and what our x value would be for the y-intercept to find both of them. So for the x-intercept, I know that y has to be 0. So therefore, I would have 6x plus 18 times 0 equals 54. So we know that this is going to 0 out. So then I end up with 6x equals 54. And then to solve for x, I'm just simply going to divide everything by 6. And I find that x equals 9. So my x-intercept is 9, 0. Okay, and then to find the y-intercept, I know that my x value has to be 0, so I'm going to plug in 0 for x. So I'd have 6 times 0 plus 18y equals 54. Okay, and then I know that 6 times 0 is going to 0 out. So now I have 18y equals 54. And now to solve for y, I just divide everything by 18. And then using my calculator, I would say 54 divided by 18 to find that value, and that would be y equals 3. So therefore, my y-intercept is 0, 3. Okay. 13, it wants us to label each situation as either continuous or discrete. So remember, for continuous, we are measuring, and for discrete, we are counting. So number of text messages sent today, that would be something that we would count, so therefore this is discrete. 2 says the number of bottles of water consumed this week. So again, this would be something that we would count. We would count the number of bottles of water. So this is discrete. And 3 says the amount of water consumed this week. So when we're looking at the amount of water, that is something that we would measure. So therefore, this would be continuous. Okay, moving on to 14. It says the graph below shows the height of a rocket launched from the ground. What are the domain and range of the graph? Okay, so for the domain, I know this is talking about the x values. So I'm looking at from here to here on my x-axis. I can see that my smallest x value is going to be 0 and my largest x value is going to be 10. And since all of my points here are connected, that means I have a continuous graph, which is important because that's how I determine how I'm going to write my domain and my range. So since it's continuous, I know it's going to be between these two values. So I would say 0 is less than or equal to, right? And I'm saying it's equal to because there's no open circle here. So 0 is less than or equal to x, which is then less than or equal to 10. Okay, so now for the range, remember this is our y values. We're looking to see how far down our graph is going and how high up it's going. Okay, so I can see that the smallest y value that I have is 0. So I'm going to say 0 is less than or equal to y, and it's equal to, again, because there's no open circles. And then it's going all the way to 400, so then it's going to be less than or equal to 400. Okay, number 15. 15 says, select the answer choices below that represent the graph's domain and range. Okay, so for our domain, we are focusing to see how far our graph is going from the left to the right. So for the left, we see it's going all the way to -4, but I also notice that we have an open circle here. So I know it would have to be -4 is less than x. And I'm using this method with the inequalities, right, because this is a continuous graph, because all the points are connected. And then all the way over to the right to 3, so it's going to be less than 3. And again, we are saying only less than because we have an open circle here. Now for the range, we want to see how low we're going. So I see my smallest y value is 1, and this time this one has a closed circle, so we're going to say 1 is less than or equal to y, and then we're going all the way up here. This is how high it reaches up, but it's only going to be less than 5 because again we have an open circle there for that one. So let's see, our answers would be for the domain. It would be A, and then for the range it would be E. Okay, 16. It says, what are the domain and range of the table below? Okay, so since they're giving us specific values, we're going to treat this like it's a discrete function. So we're going to list the exact values that they're giving us. They won't be within from one point to another. So in our set notation for our domain, we're focusing on our input values, our x values. So we have -3, -1, 1, 3, 5. Okay, and then for our range, we are focusing on the output, our y values. So we're going to start with 3.25. And then 3.75, and then 4.25, 4.75, and 5.25. Okay, so moving on to number 17. Given the equation f of x equals -3x plus 6, complete the table and identify the domain and range. Okay, so to complete our table, all we have to do is, on our calculator, go to y equals, and we're going to input our function here of -3x plus 6. Then we're going to hit second graph to go to our table, and we want to start at our x value of -2. So when x is -2, our y value is 12. Whenever x is 1, our y value is 3. When x is 4, our y value is -6. And then whenever x is 6, our y value is -12. Okay, so now our domain, again, is going to be all of our x values, and we're going to treat this as discrete because they're giving us specific values. So in set notation, we're going to say -2, 1, 4, 6. And then for our range, we're going to list our y values. That's going to be 12, 3, -6, -12. Okay. 18. What is the domain of the function n if its range is -33 negative 15, 13, and 19. And n of x is equal to 4x plus 5. So right here it tells us, it gives us a hint to make a table. So let's do that. So over here we have n of x, that's representing our y, and that's going to be our range, right? Because range is our y values. So we know that we have negative 33, negative 15, 13, and 19. So I only want to find the x values for these y values right here to list out for my domain. So going to y equals, I'm going to input my function here of 4x plus 5. And I'm going to go to the table, and I'm going to look first to see where I can find where y is negative 33. I don't see a y value of negative 33. I do see where y is negative 15, and I see that that one is negative 5. Maybe they meant, let's just say this. Let's say they meant to say it was negative 35. So we're going to say this is negative 35. So whenever y is negative 35, we see we have an x value of negative 10. Okay, now I'm looking to see when y is 13. So when y is 13, I see that I have an x value of 2. And now when, I don't have a 19. Since I don't have a 19, I'm just going to use 29. I'm going to just change the question up here some. So whenever y is 29, I see that x is 6. So therefore my domain is going to be all of my x values here, and we'll list them out as discrete since they're specific values. So I have negative 10, negative 5, 2, 6. Okay. 19 says, a jeweler charges $15 for each ring she steams and cleans at Pearls Shine Bright Like a Diamond kiosk at the Cypress Outlet Mall. If she expects to clean between 26 and 30 rings per day, then what are the possible amounts of money the jeweler can earn in one day? Okay, so let's first figure out what our equation would be. It says a jeweler charges $15 for each ring she steams and cleans at this location right here. So that means our equation would have to be y equals 15x. All right, so x is going to have to represent the number of rings, because depending on how many numbers of rings that she cleans is going to then determine what is it saying? The amount of money the jeweler could earn. So amount earned. And it's saying if she expects to clean between 26 and 30 rings per day. So 26 to 30 rings per day. So from my table, and it's saying between this number of rings, we know that this is talking about the x values. So we're going to say 26, 27, 28, 29, and 30 here. And we're creating a table so that we can easily see what our y values would be, since once it's asking for the possible amounts of money. So it's asking for the range. And we also know that this is going to be listed out in specific values because it's talking about money, and money is something that we count. We don't measure it. So going into y equals, I'm going to say 15x, going back to my table here. So I want to go to where x is 26. Okay, so when x is 26, my y is 390. 27 is 405. 28 is 420. 29 is 435. And 30 is 450. So we know that our range will be 390, 405, 420, 435, and 450. Okay, so that completes the Linear 3 test review. So be sure to hold on to your test review so that you can turn it in to me tomorrow before the test to get your 5 extra points for the test. And then I need you to complete Mondays and Tuesdays homework because they are just more practice for the test that we have tomorrow.